So in this example, we have 4 to the power of x plus 5 equal 1 over 64 to the power of x plus 2. Now, usually with fractions, the whole thing is being powered by the exponent. So you're usually going to see fraction with parentheses on the outside powered by the exponent. In this case, 1 over 64 is being powered by x plus 2. Now, if you don't see with parentheses, that means that the exponent is only either to the numerator or to the denominator. But you see with the whole parentheses, it's to the whole fraction. Now, same as before, we need to get into same base, but we have a fraction on one side. So let's see, could we get 64 into the same base as 4? Which is yes. Since 4 is the lowest base, now I'm going to write the left side the same because we gain 64 into 4. Now 64, again we only focus on the denominator. 64 is the same when it's 4 to the third power. So 64 is the same as 4 to the third power. And again, I only change 1 over 64 to 1 over 4 to the third power, and the exponent stays the same, so x plus 2. Now, again, to go from fraction to a whole base, when there's an exponent, all we have to do is convert it to a negative exponent. So, again, the left side stays the same. I'm not doing anything to change the left side. But the right side, if we want to go from fraction to a whole base, we just change the exponent to negative. So it's going to be 4 to the negative third power. And then I carry the exponent, the original exponent, from the beginning. So the given exponent from the beginning, I carried with the negative 3. So x plus 2, x plus 2, x plus 2. Now, the bases are the same. So what we're going to have is just the exponents equal to each other. So since the bases are the same on both sides, therefore the exponents have to be the same on both sides. So that means x plus 5 equal negative 3 times x plus 2. So, and then don't forget, since we have that negative 3, I'm going to distribute that negative 3 to the x and to the plus 2. Because we have a number with a negative outside of parentheses. So, x plus 5 equal negative 3x minus 6. Alright, so I'm going to bring the work here since I ran out of space. So, x plus 5 equal negative 3x minus 6. Alright. So, if I want to solve for x, I want to get all my variables on one side. So, let's say I want my x's to be on the left side. So, I need to get rid of negative 3x. So, the opposite of negative 3x is plus 3x. Since it's there on the right, I'm going to do it on the left. And say I want my numbers to go on the right side. So from the left, I need to get rid of the plus 5. So opposite of plus 5 is minus 5. And then I do it again on the right side since I did it on the left. So my x's cancel out on the right side, but my numbers remain. So negative 6 minus 5 is negative 11. And then the equal sign. And then on my left side, the 5's cancel out, but my x remains. So x plus 3x is 4x. So we have 4x equals negative 11. I'm going to divide by 4. So x equal negative 11 over 4. So that's our answer. When we're working with exponential equation that has a fraction. So x equal negative 11 over 4. Now in this example, it has fractions, but unlike the last example where it had only one side with fraction, this example, both sides have fraction. So what we're going to do is focus on the denominator, which is 9 and 27. So what's common between those two is that they can be converted to a smaller base of 3. So let's take a look. So 1 over 9 will be the same as 1 over 3 squared, because 3 squared is 9. The whole thing powered by x plus 4. And then equal sign. Now 1 over 27. So 27 can be converted to a small base of 3. So 1 over 27 is the same as 1 over 3 to the third power. And the whole fraction is being powered by x minus 7. Alright, now we got the same base, so let's convert it to a whole base instead of a fraction. So 1 over 3 squared is the same as 3 to the power of negative 2 times the original exponent, x plus 4, equal, and then 1 over 3 to the third power is the same as 3 to the negative third power times x minus 7. Alright, so now we have same base on both sides. So since the bases are the same on both sides, meaning the bases are equal to each other, therefore the exponents has to equal to each other. So I'm going to write the exponents. So negative 2 times x plus 4 equal negative 3 times x minus 7. And just like before, since we have a number including a negative outside the parenthesis, we're going to distribute. In this example, we are distributing on both sides, the left side and the right side. So, negative 2 times x, negative 2x, negative 2 times plus 4 minus 8. Negative 3 times x is negative 3x. Negative 3 times minus 7, that's plus 21. Alright, now I'm going to bring the work over here since I ran out of space. So it's negative 2x minus 8 equal negative 3x plus 21. Alright, now say I want to get all my x's on the left side. So say I'm going to do this step by step. So what I'm going to do is I'm going to get my negative 3x, get rid of it on the right side. So what's opposite of negative 3x is plus 3x. So since I did it on the right side, I got to do it on the left side. So my 3x will cancel out on the right side, but I will have x on the left side. So negative 2x plus 3x is just x. Bring down the minus 8, and then bring down the 21. Now say I want x to be by itself on the left, that means I need to get rid of my numbers. So the opposite of minus 8 is plus 8. Since I did it on the left, I gotta do it on the right. So my 8s will cancel out on the left, but my numbers will remain on the right side. So x equal 21 plus 8 is 29. So our answer here is x equal 29. That's our final answer. And then if you want to check if that's true, all you have to do is plug 29 into both x. And then work out the same as before, convert it into small base, and see if it's the same on both sides.